there's the handle in his hand. Fortunately, he had a hand-thrown system, and he took it out and he threw that and came down safely. The bottom line is we found that the rockets themselves are 99.9% reliable. But what we're seeing the failures that are happening happen with the bridle routing, the trigger mechanism, the harness design itself. Maybe you remember G.W. Meadows. When ballistics came out, he was very excited about showing this group of pilots how well they work. So he went over to Saboba and launches, and everybody's waiting for him to fire, and waiting and waiting and waiting. Well, he couldn't pull the handle. It just wouldn't pull. He tried both hands, it wouldn't pull. He came down and landed. He put both feet against the rocket, and he yanked as hard as he could. Finally, it pulled. There's another pilot, what's her name? I forgot, San Diego pilot, and Sandy King. And what happened with GW is they had the handle here, and then there was a cable.
Well, that was really
and there were too many twists, too many turns, and so when he pulled on the cable, there was too much friction for it to release. It was binding. So Sandy King, same problem. And when they looked at her system after it didn't work, they found that there was only a total of 90 degrees of bend, which is what their requirement was, that it was put in properly. Yet still, on the ground, it took 93 pounds of force. And she could never pull that off to get it out.
You've been talking a lot about the importance of finding blue air. Now, what happens if the rocket fires straight into your sail?
That's been a problem. For a while, the rocket manufacturers were putting points on the rockets. And they were saying if it hits the sail, it'll just go straight through. Well, I know one pilot who was an instructor at Wind Sports, and it didn't hit a sail, but it accidentally deployed when he was coming into land. You know, this man's Anita Bush reached up and grabbed his handle. The rocket fired through his harness and buried itself. This was around Mina in the Owens Valley, and it buried itself like 8 inches into the ground. Put a hole like this in his harness. As far as the sail goes, they did some tests, but it was all on a nice tension tight sail. So I don't know. This is another one of those questions. So the bottom line of this is today, I don't think ballistics is the way to go. At one time, my feeling was that the canister, instead of being on the pilot, really belonged up on the king post. Because when you look at these parachute deployments and talk to people who've had failures, if they're in a tumble, half the time they're pointing the wrong direction no matter what, right? If you're tumbling. But if you're in a spin, most of the time, pilots are below the wing in the rotation, which means if you're going to put your rocket someplace, the best place is to fire it upward to avoid your upper rigging. So I developed a concept and drew it up and sent it over to Dan at BRS, and the concept was for a section of king post, and the manufacturers would have to put these little, they'd have to okay it, but where you could cut out a section of your king post, replace it with what essentially is the launch tube. The actual parachute is housed in the double surface, so you don't keep putting it on and putting it off. What you do need to do is keep pulling on and off the handle to activate it. And then, if you're in a bad situation, you can pull your ballistic system that would fire the parachute away from the upper rigging in one of the quadrants, which is a really good direction. And I was real excited about this, and BRS actually was very supportive of the concept, but just about that time, topless gliders. became popular. So obviously BRS at that point did not want to pursue it. So my feeling about ballistics is today, if you look at the skydiving industry, electronic activation devices have come a long way in just the last 5 years. And my real feeling is there is a place for a ballistic system with an electronic activation device. I think a lot of the problems we've seen have been in the mechanical devices with the rockets. And it just has not been developed at this point. Okay? Okay, so these are the problems that we see. Now, how do we stop these problems? Well, obviously, you keep up with new developments. What's going on in the industry? And you keep up with the new developments with a grain of salt. You look at it and don't assume that something that's new is really better. Just like I love to try to make things fail, you should also try to think in terms of how can I make this fail? How can I make it not work? Is this new wing, is this new design, is this new concept really better or not? Prime example is there's a parachute that has come out and it's pull down apex, but they put a cover over the where all the apex lines come together. And their marketing approach is that they actually are smoothing out the airflow so you don't have the turbulence above the parachute. Well, that might sound really good. However, if you know anything about parachute design, you know that you're trying to get as much turbulence as possible right above the parachute because that's how you get more drag. And so here, something that's new, even if it did do what they said that it's doing, which we don't think that it really is, but if it does, then they're not increasing the performance at all. They just are not understanding the airflow dynamics around parachutes. You want to inspect your safety system. Not only your own safety system, but everybody else's too. Now, what's your safety system? It's your parachute, it's your hang loop, it's your carabiner, it's your harness. Anything that's connecting you to your parachute or connected with the parachute is part of your safety system. Your system is only as strong as the weakest link. Well, how long does that have to be? I think I handed out, I handed out an article, and in the article, there's a formula there, and you can figure out for yourself, with your weight and your system, how strong does that weakest link have to be. Therefore, if you have a harness system, a parachute system, a hang strap, whatever you have, a carabiner, you know how strong that weakest link needs to be. Okay, you want to repack often. Now, officially, I'm supposed to say you need to repack every 6 months, but very realistically, I think once a year is very appropriate. When we repack, there's certain things we look for. First of all, we re-inspect everything that people have inspected before. We look for any time bugs have crawled into the parachute. What'll happen is you'll find this brown spot, and sometimes when they die, they have a acidic composition, and you'll find holes in there. So we're looking for the holes. We're looking for damage left by little bugs in there, urine stains, that kind of thing. We're looking for dirt. If you have dirt, if you notice the parachute material is very fragile and it's very lightweight, it's not real strong. So if you get it dirty and it stays in your container and year after year it just moves a little bit, it turns like sandpaper and it becomes weaker. It causes abrasive damage. You want to repack often, once a year at least. You want to perform a knee test. After we pack your chute, we put it back into your harness, what you're going to do, let's see, I'll grab a harness. And to the sides of the harness so that your parachute's in the middle, and you're going to take your knee, and your knee is going to simulate the curvature of your body, and you're going to pull, okay? In this way, and you go down a little further, and you pull. And if you hear Velcro, then you want to put your parachute down on the floor after the repack and sit on it, and wiggle back and forth, and make sure your Velcro's nice and secure. Then you pick it up and do another knee test, okay? This will help avoid accidental deployments. And again, a freshly packed parachute is more prone to accidentally deploying because you still have a lot of air in it. We'll go over the knee test again, don't worry. Okay, you want to upgrade your equipment. As things come out which are real improvements, you have to decide, is this a good thing or a bad thing? If it's a good thing, you might want to go for it. We talked about paraswivels, how the paraswivel really did solve a problem. Now we see that there are some complexities and some problems with the paraswivels, but they're not insurmountable. You keep up with the developments. Parachute bridles. At one time, we were making parachute bridles 15 feet long. Well, with today's gliders, that's not long enough. You need to make sure that your bridle is long enough. Now, how long is that? Well, when you threw your parachute, your bridle stayed connected to the harness all the way to this point, all the way to the point at which it went into the parachute container. So this distance doesn't count. The distance from here below your control bar out to the furthest wingtip is the distance that you're going to have before the parachute opens. That has to clear, you have to clear that distance in a throw in order to have the appropriate size bridle. So if you have a bridle that's shortened because you put a paraswivel in it or whatever, for whatever reason, you want to just take a measuring tape out to the next time you fly and see what that distance has to be for your system. If that's too short, what can happen is your parachute will go out and the lines can be folding over the edge or trapped in or wrapped around the edge, and your parachute will not open. This is exactly what happened to Steve Pearson and a number of other pilots. Okay, you got to make sure to keep up with new developments. Okay, hook knives. I talked a little bit about your hook knife and how on the plastic ones they can twist and separate the blades. So if you know this, you also know when you use it, you can just use it straight and it'll be a nice solid hook knife. There's one hook knife here that has only one blade, and so that has its limitations. It's just not as easy to cut as with the two blades. Harnesses. Okay, you want to keep track of developments in harnesses. A lot of the early backplate harnesses you couldn't get upright. Many of the harnesses today, you're getting nice and upright. No problem with them. You need to make sure whichever harness you have, that you have it adjusted properly. In the handout that I gave you, there's a whole checklist of if you have a problem with this or that, what you can do with your harness to help solve the problem. What's really interesting is when you see a problem, whether it's fuzzy damage on your harness or whether it's, not being able to get this out or that out, you need to become an investigator. Not only do you need to solve the problem, but you need to understand what caused it in the first place so you don't have to repeat it. You need to pre-flight. Pre-flight your bridle routing over and over and over. If your bridle's starting to slip out of your container and forms this big loop, make sure to stick it back in. If the bridle is stuck too tightly in the container and starts opening the Velcro, you've got to pull a little bit out. It's mainly common sense. As long as you understand it, it's just common sense. Hang strap. Hang straps are real easy to change. If you have a hang strap that's not the right height for your glider, for goodness sake, just get the right height. Anybody here know Tom Sapezia? I can't pronounce his name. Okay, what happened with Tom is he had an extra hang loop to add a little distance to fly. And when he hooked in, he thought he hooked in properly in the hang loop, and in fact, he launched, he radioed his wife to go on and drive down, and seconds later, he was gone. He had not hooked in properly, and the loop he used to hook in was only staying there by friction. And I think it was like 30 seconds after launch, it unhooked and he went into free fall. This can happen too easily. If you need to extend your hang strap, if you need to shorten it, just get one the right size, please. You don't think it'll happen to you, but neither did Tom. So you need to pre-flight. Safety locks, parachute container closure, hang strap, carabiner. And more than anything, you now have a responsibility to other pilots. And I know today's been a long day and there's a lot of talking, and I know getting dizzy and spinning is not really fun, even though it sounded like it was going to be, but in reality it's not. In experiencing what you've experienced and learned what you've learned today, you have a responsibility to talk to other pilots about it, to share this knowledge, to ask questions, not, oh, I would never get behind that ridge, I wouldn't get rotored here, I wouldn't do that, but instead think in terms of, if you're in that situation, what will you do? What are your options? What if your plan A didn't work? What are you going to try next? And in talking and considering these things, you're going to become safer pilots. Okay, at the very last page of this little handout, you will find a quiz. If you could take some time, and we're almost done, but if you could take some time and just fill out the questions, it's really helpful to me. And also, if you need to finish up your practice deployments at this time, go ahead and please finish them up, especially trying to climb out of your harness. Okay, this is something important that you need to learn how to do. And in just a few minutes, what I'll do is start packing parachutes, and I'll go through a demonstration of how we pack and why we pack it the way we do. And we'll call it a day. Okay? Well, thank you very much. Do you need a pen?
Okay, I was just asking Betty how we go about stitching these, because I got to put a paraswivel in mine. So
Okay.
the requirements are?
Well, I like to use the 6 inches of 5-cord thread in what's called a 3-point, or some people call it a walking W. And just like this is perfect. Now, if you don't have this thread, now this 5-cord thread is 55-pound breaking strength.
Oh, okay.
If you have a weaker thread, what we can do is calculate out the stitch pattern, because the bottom line is your joint efficiency needs to be 6,000 pounds.
Okay.
You don't want it weaker than that.
Now how about the speed that the stitch is going at will determine the spacing between each poke through, or whatever you want to call that? So is there
What we're looking for with 5-cord thread, we want 5 to 6 stitches per inch.
Oh, okay.
Okay, if we go beyond 11 in even regular E-thread, then it actually weakens the material.
You put too many holes through it, yeah.
So here we're looking, 5 to 7 stitches per inch is actually a good number with the 5-cord thread.
So that 3-point
and the
actually
way,
has It's actually like 3 sets of V's.
Yeah, the way it's sewn, you start here and you have your first pass, second pass, third pass, fourth pass, fifth pass, sixth pass, and then here you lock it. So you actually start on one end and finish on the other end. But structurally, you don't count the overlap as an additional.
Oh, one
string.
layer is layered on top of the other one.
Yeah, now
Right
here.
for the first part
Okay,
there, yeah.
here they stopped right about here, which is just fine.
Mm-hmm.
You just want to make sure it's locked.
Right. So
But-
2 inches of overlap to
Yeah,
seal
although
it in.
I like to do the
A whole
full
stitch.
length of overlap, just because it's easier to cut the threads without hurting other threads that
Okay.
way. But no, this is done quite nicely. Now, if you were installing a paraswivel, what you would end up doing is,
Well, we can go over that tomorrow because I'll bring in
Yeah.
my chute and my paraswivel
Oh,
and we'll look
okay.
at where it can go in. Sure.
that'll work. Okay, so packing a chute. Okay, if you notice, first we're going to do a line check to make sure your lines are. And just for fun. Okay, we have a twist here. See how it's tangled? And so we're going to start off untwisting. Now, it wasn't like that when you started the day. It probably
Right.
happened with
From-
everything that we were doing.
Yeah, well, it was all tangled up at the other end there when it came deployed.
Okay, it's easiest for me if we just oh, is this attached?
That's right.
How hard is it to unattach it?
I can do that because I got to take it out of that stitched
perfect.
main thing anyways.
When whoever put the packing tabs on, they did not put it on in a configuration which would allow this to be the same length. This comes from Free Flight Enterprise, and in fact, I coordinate with Gary DeReese, the owner, quite frequently. In fact, we just finished an article together that we're calling Scary Parachutes.
Oh.
And yeah. But,
Is this one of them?
no, this is one of them. But anyway, the reason this is too long is because up here, these packing tabs, which is where the parachute folds, were actually located in a position where the lines are not even with the pull-down part. And so if these had been located in a slightly different position, they would all be even. Since they're like this, what I'm going to do is rubber band the excess, the extra length here. And the reason is because the center line, if it's too long, it can get wrapped around the lines, and then you can have damage. As it unwraps, you get friction heat damage. And so just as a packing aid, so I know it's not going to wrap around, I'm going to just bundle it up at the top here and throw a rubber band on it. So it's no big deal.
Now, isn't the fact that it's longer, is that going to affect the flight characteristics?
Okay, the way the pull-down apex, yes it does. The way the pull-down apex works is this. You have a round parachute, and conventionally, well, a flat circular chute is called a flat circular because literally you can lay it down on the floor, and just like that circle on the floor, it will just lay flat like that. And that's why it's flat circular. The conical shapes were designed so that if you laid it out on the floor, you could pick the apex up a certain amount and it would be like a cone. You might, in skydiving, you hear about 30-degree conicals a lot. What that 30 degree refers to is how many degrees up from the floor the parachute's going to be held to form the circle on the floor. So when the pull-down apexes started, actually Jim Hanbury worked extensively on PDA designs, and in the early 80s he found that if you pull down the apex, you're actually getting a higher drag coefficient, more drag, and it's coming down slower. Now, with that, in the early PDAs, they would oscillate all over. They would dump air, and some of them would never stabilize. They'd just keep dumping all the way to the ground. So it took a lot of research and designing and re-engineering to design parachutes that were designed for the apex to be pulled down. Some of the first ones were flat circular designs where they just pulled it down, and it wasn't designed. That's why they were getting all this instability on it. Now, when the parachute opens, we talked earlier how the air has to come in through the air channel, and it inflates from the top out. When you pull the apex down like this, and here, this is the top of your parachute, and it's being restrained in a downward fashion. That means the air is going to fill up, but not from the top. It's going to fill it up where it's folded. And instead of the load being transferred to all 20 or 22 lines, the initial load is being absorbed by this line. And that's why it needs to be this beefy. Theoretically, this line has to be the same strength as the sum of all the other lines. Now, these lines are really overkill. These are 400 pounds, and in a nice symmetrical opening, you could do with 100 pounds, but you always need a safety factor in there. And so that's where we get that. Now the question becomes, if you do have a center line failure, what happens? What we found happen is this. Depending on where it fails, sometimes the parachute just pops up and you have a round parachute. And so you come down safely, no problem. However, in a couple of our tests, we've had center lines fail. They start to thrash erratically. They start to whip around other lines, damage other lines. They've torn through other lines. And so it is important to keep a good, strong center line. So, yeah, this is very important.
Oh, you know what I mean? I guess my question was, once it is fully inflated, the fact that this line, you were suggesting it was a little too long, right? So isn't that going to affect the shape of the parachute?
No, because in packing, in the design itself, it was designed for a certain shape, and what happened with this particular chute is they mismeasured where they put the packing tabs on, which are inconsequential.
That's just for packing.
It's not just for
when
packing.
It's open.
Oh, it doesn't affect.
So, right, so it doesn't matter at all. What does matter, however, is making sure that your center line is centered. I've seen some pull-down apex chutes where the center line is way off to the side, just in the packing job. And what happens under a high-speed deployment is it goes, centers itself. And here again, we have friction, heat, potential damage. So that's a problem. In the later versions of the same parachute, what Gary started doing is just bar tacking a little line here and here so this couldn't slide. So it kept it centered all the time. And if you notice in the blue parachute, what we do, in fact, can you drag the blue parachute over, please? I'll show it to you now.
So when this thing is flying, though, there'll be constant
Pressure.
pressure on your center line.
Right.
That's what keeps the center pulled down.
Yeah, just to show you some, thank you. Okay, in an attempt to idiot-proof this, again, you see the real beefy center line, which is important, but here, you see how there's no way for it to slide anywhere. Now, this is more labor-intensive, but it's more idiot-proof. And back in these days, we were looking at meat savers. Okay, that's the code name for the old-style parachutes, because they were just designed to save your meat, and they do that quite nicely. But, break bones, but whereas this is designed to come down as slowly to be the best possible parachute that we could design, regardless of the labor and the cost. So, okay, so first we do a line check. Well, we check to make sure the bridle is the right length. We do a line check to make sure that they're...
So this thing will keep me alive, but I'm still going to get all broken up.
Yes.
That's
It'll
reassuring.
come down pretty fast.
Like jumping off a 15-foot roof?
Well,
We'll
the
see
rendering
tomorrow.
plant will give top dollar for
Okay,
you.
we're going to...
We'll see tomorrow.
Uh-huh.
Live parachute deployments.
Well, videos.
Okay. Gee, I thought we were going to toast Steve up.
We're just going to Place Louis Riel,
Yeah.
23rd.
Drop me.
Okay, as I look at the lines, I'm also looking for any snags. If you notice down here, there are a few little snags, and you see some raw ends coming out. And this is also the end of the finger trap. This piece goes around the webbing, and then it's inserted into itself and finger trapped, and this is just the end, towards the end of the insertion. So I'm not concerned with that. If I really wanted to get compulsive about this, I would just take something to pull this inside
Push it
so
inside,
that it
yeah.
doesn't, yeah, so it tucks in. So as you look, when you work with parachutes, you want to feel a lot, because sometimes your fingers will tell you things that your eyes don't see. And your lines look really good. And so here I'm just going to take up the excess with a rubber band. And this will pop right off when you need it. It's not going to affect anything. It'll just make sure that your center line doesn't twist around.
You're going
Okay.
to leave that on.
Yes, I'm going to leave that on. Okay? You see a twist? Is it okay?
Well, I guess when you pulled that way, I thought you were bringing it around one of the smaller lines, but I guess.
Oh, okay. What we do is we flake the canopy. What I'm looking at here is the V-tabs. And V-tabs are this little webbing tab here. And the purpose of this is if the air hits the outside of the parachute and starts to pull this direction, that the stitching here and here keeps the line on and secure. Without the V-tab, with this kind of stitching, if the line starts to pull this direction, once it starts ripping, it takes 23 pounds for this line just to go and rip off. That's it. So V-tabs are real important. Your parachute, they used a V-tab machine, which is quite nice. It's really pretty the way they do the stitch, and it's nice. They step on one pedal and the stitch pattern just goes and it's done. So we look for the construction like this. We need reinforcement tape both at the skirt and at the vent. The idea of the reinforcement is you want to have a superstructure holding everything together. It's like a skeleton. And even though this parachute would be much prettier if this were on the outside and this were on the inside, it would not serve its function. Here, when you think about it, the parachute is inflating and you want the structure to hold everything together. Now, for it to hold together, it needs to maintain this structure, so even under higher speed loads, without the reinforcement tape at the skirt and mostly at the vent, you can break through that, and if you break through that, you don't have a structure holding together. With this structure, if your material rips somewhere or another, no big deal. It's still all being held together. It's not a catastrophic failure. So we look at that. If you look at the little squares, let's find a yellow panel, that's easier to see. Okay, this parachute uses block to bias construction. That means that the squares are parallel to the seam on this side and diagonal to the seam on this side. Well, if you take your hands and pull parallel to the seam, you find that there's not a lot of stretch that you can feel. But if you go to this side and go parallel to the seam, there's a lot more stretch. So the stretch issue is important because under a high-speed load, you know that this side of the gore is going to absorb the load before this side's going to. The load will not be transferred to this side immediately. It will be absorbed here first. So if you look at a canopy with this construction after a high-speed opening and really look at the details, you'll find that this side's nice and flat and there's this little bulge over on this side that then flattens out. In good parachute construction, what we look for is fullness. And if you look inside, you'll see that there are puckers on the seam here. Well, that's important. We want that. The reason we want that is under a high-speed load, we want the energy to be absorbed as the webbing stretches before it's transferred to the material. This is very lightweight material, very fragile, but it'll all stay together and it can do tremendous things, like you'll see tomorrow, in the event that it's loaded properly.
So every second panel is like this? Like
Well,
parallel and then diagonal?
yes, on this parachute it is. Now, the beauty of this construction is that you have literally zero parachute waste. When you cut your parachutes, essentially you can cut this huge triangle like this, and you can get 4 gores and no waste. And so it's very efficient for material use. However, it does not give you the best parachute. If we take this and pull, on this, you can see how it's loading the one side. Here, can you pull? Yeah, give it a good pull. Good. Okay, here you can see how it's loading the one side, nice and flat here, yet it's puckering and still has room to stretch on this side. Okay? If there was no reinforcement tape with this construction, what we would find is the seam torques and the holes where the stitching went in and out start to elongate, and we can find damage in high-speed deployments.
How do they do the puckering when they're sewing?
Well, the feed dogs on the sewing machine naturally pucker, and you can tension those, you can arrange the height of those to give you more or less of what you need. So it's a sewing machine adjustment. It's also a sewing machine operator adjustment as far as the whole sewing process goes. Some parachutes that are coming out of Brazil and out of Italy have no reinforcement tape, and the seams are nice and flat. So when you pack it, it lays beautiful on the table. But when you think about the function, when you think about a high-speed deployment with that, there's nothing except the material to absorb the loads. So in fact, we did see one of those fail in a test. I like to make things fail. We threw it out of an airplane, and sure enough, we thought it was going to fail, and it did. So this is from Portugal. There's a company in Brazil, and also there's another company, and I think they're in Italy, that we're seeing some questionable construction coming out of.
It may be all right under a very slow speed opening, I guess.
Right, and this brings us into testing. Have all of you heard of DHV testing? The Gudesiegel?
No.
Okay. This is a testing procedure that they use in Europe, and they give a lot of credence to it. And when they test paragliders or hang gliders or, paragliders and hang gliders, they have wonderful tests, and they do a real good job. However, when you look at their tests for emergency reserve parachutes, they're ridiculous. They are throwing these chutes off of an 800-foot bridge with 20 pounds on it and claiming to be testing. Well, it does not. Any of you who have a Litec Vario, or actually who have a Ball Comp Vario or a Flytech Vario, can put your instrument package on your parachute and throw it off of any altitude and get more information than what they're getting. They have a fellow sitting there sighting to see whether it was fully open. Well, what's open mean? You know that there are different levels of deceleration. When the parachute comes out of the bag, it has an initial deceleration. As it starts to inflate, you get another deceleration, then you get a rebound, then you get another deceleration. What are they talking about? When is the parachute open? And it's very subjective, but that's a whole nother issue, because we're hoping that somebody else is going to be coming in very soon who will update their testing procedures. So anyway, the point of this being that a lot of the companies that are building parachutes are not parachute manufacturers. They're not learning from things that have been known in the skydiving industry for many, many years. They have the mentality that if it's not made for paragliding or if it's not made for hang gliding by a hang gliding company, then it's not good for them. Well, that's wrong. We have to learn from related air sports. You know, we don't want to have the same problems, yeah. So, anyway, sorry, I'll get off my soapbox on that. What we're going to do is, so we look at the construction of the parachute, and we look at the stitching, and if you notice, this white on white stitching looks beautiful, because you can't see the defects. If you notice, like I built this parachute, and we use black thread, and the reason we use black thread is to make inspection very, very easy. However, if the sewer just hiccups, then it's really bad because you can see that. And so it doesn't look as pretty, but it's easier to inspect. Okay, this is how we flake the parachute. Basically, I'm looking inside, and what I'm looking at is I'm looking at the stitching, and in looking at the stitching, if there's a straight line instead of this kind of line, then they ran out of thread, they ran out of bobbin. Sometimes, and we've seen this at parachute clinics, you can look at a seam and it looks just perfect from the outside, and then you look on the inside and it's only the tension of the pressure of the thread going in and out of the hole that's
Holding
keeping
it.
that thread in there. They ran out of bobbin.
So the backside isn't stitched
So,
yet?
yeah, so we look very carefully at the back side also. We look at the material. If you look inside, if there's a hole in the material, you can see the light just coming through. So it'll catch your eye really, really fast. So that's what we're doing. I'm also shaking it, and what'll happen is the dirt that has gotten in there will all fall down to the last gore. So if you've been around a lot of dirt or sand, we'll be able to just pull it out of one gore instead of trying to get it out of all of them. Of course, if it's really bad, then we have to hang it up. Okay, with the PDA, you have to make sure that your center line is centered, and with some, there's a little trick you can do to lock it in place. Okay, from here, we're going to put it on the table. Two methods. Some people prefer nicely laying it down like this, but I like the flip method. That's just swinging it, flipping it down. Either way is fine, as long as you end up with it down on the table. Okay, from here, we're going to count half the gores on each side. So we have 1, 2. As I count, I'm also pulling a little bit to help smooth the fabric out. How many is that?
6.
7. Okay, so we know we have 10 here, and then we go to the bottom one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, from here, we're going to go follow your bottom gore up to the top, and we're going to flake it at the top.
I thought it said a PDA 22 somewhere back there on the cord.
2, we'll find out.
Because you counted 20.
3, 4,
Yeah, that's Barry with a black belt marker marking 22 so he could charge me a little more.
5, 6, 7, 8, 9, 10. And on this side, 1. It's real important to count 4 places with the pull down apexes. 2, 3, 4.
You say it's important to measure 4 places?
To count
Oh, I see.
And
All 4 corners. Yeah.
all 4 corners, because it's too easy for something to get hidden and you don't notice it. And on a high-speed deployment, again, you have friction heat damage. What was that? 7, I
Oh, does it
think.
say 20 on it? Oh, okay.
I like the story though.
8,
Maybe, you know what? Maybe it was that other one I read 22 on. I'm not
Entirely
sure.
believable.
9, 10.
Oh, it's to
There's
be edited
11.
big time.
Let's count again.
11
1,
to 21.
2,
20.
3, 4, 5, 6, 7, 8, 9, 10. Okay. As we smooth the air, we're pushing the air out. We always go towards the opening. Okay, we talked about how important the air channel is. So here we're going to force air in the air channel by doing a 45-degree fold. This way, as the parachute comes out, these are already folded up here, and so it's going to minimize the chance of air entering one of the folds wrong. Many of the European models, they're folding the gores just like that. What we find happens in a high-speed deployment, if with a lot of force here, these will naturally fold up like that, and the air then is directed down to the air channel. In slow-speed deployments, however, when this is wafting all over the place, the air might get caught here and start to inflate, and might get caught over here, and you will not end up with a symmetrical opening. Well, what's bad about that? As the parachute tries to balance itself, it's losing altitude faster as it's trying to position itself. And that's what's bad about it. You don't have to come down that slowly. So to fix it, it's real easy. We're just going to do the 45-degree fold and control, and this is the important word, we're going to try to control the opening sequence. Okay, from here, we can fold it in thirds. Okay, good. Grab this too. And then my hands are really small, and so I like to fold it in thirds again. Some people fold it in thirds, then fold it in half. Either way is just fine. Just doesn't matter. Okay, now we want the parachute to go in the deployment bag just opposite of how we want it to come out. In Europe, there was a problem when they packed a deployment bag, and actually instead of S-folding it like we're going to do like this, they flat packed it and they kind of piled it up back and forth on top of each other, crunched it down, slid it into the bag. Well, the bag they were using happened to be either very stretchy material or else have reinforcement tape on the outside that shrunk. I don't remember which it was. In any event, when the pilot went to throw a chute, it was locked in the bag and wouldn't come out. Consequently, a lot of the thinking in Europe is they don't want deployment bags, they want diapers. Well, this is a whole different issue I won't get into, but these are far superior if you do it properly. And what the right way to pack this is to S-fold it into the main compartment.
Yeah, mine was like you said. It was like
Flat pack.
flat packed. Yeah.
Yeah, we don't like that. The
Oh.
reason we don't is when you pull it out, often we see everything coming out of the bag at the same time.
It did.
That's what happened to yours. And that means that it's exposed to the air all at the same time, and so you don't have that controlled deployment sequence. Exactly.
In
If-
skydiving, they'll pack it as packed.
If it were packed
This
the
was
way I'm
packed
going
by.
to pack it now,
I think this was packed by one of the big
It
The
would
big
be
kahunas.
a skydiver.
Skydiver. Yeah.
Oh, a skydiver would flat pack it, no question.
Much.
Is that who it was? You remember?
Okay,
Normally it doesn't have.
I go to the International Parachute Riggers Symposium every 2 years and teach riggers how to pack hang glider, paraglider reserves, and it's amazing how many of them just are in awe at what we're trying to achieve, because it's so different from these high-speed types of deployments. Okay, very important to take the packing assist line off.
Oh, yeah.
Okay, if this is still on, you're going to just have a little parachute where you need a much bigger parachute. There was one time that I remember explicitly where I forgot to take this off. And I found it the next year. Jeff Nielsen, if any of you know him, it was on his parachute. He's
giant,
the sweetest guy. Yeah, big Jeff.
Yeah.
Yeah, Pam's his wife. Yeah. Oh, and I felt so badly because Jeff is just so kind. And I
Hope he
was
didn't
so
need his
happy.
parachute.
Well, you wouldn't mind doing this to a jerk.
But
Yeah.
no, but I remember very clearly waking up one night at 2 in the morning, forgetting if I took this off or not. And so I worried about it all night. I got up at 6 in the morning. I call up this poor guy. I'm at work, and I call him up. Hey, can you check your pack job? I know I just sent it back to you, and I think he was in the Midwest somewhere. I know I just sent it back, but I don't know whether I had left this on or not. So he ended up checking it, and fortunately, it wasn't there, and I had to do another repack for him. But it's very important. And so as your parachute gets done, or if you have any question over the ability of the packer, make sure to just reach in there. This has to be
So
on.
you put that on at the beginning.
Uh-huh.
It wasn't on Steve's all the time.
Right. This is our packing assist line. If you have packing tabs in your chute, please put it on. Just thread it through all the little loops, and that'll make packing much easier for me. Okay, so from here, we're going to,
It almost sounds like it'd be worth it to have a checklist so that you have to check that you put it on and check that you took it off.
well, actually, if we were doing this at my shop, we actually have this right on here, and we put it, and we
Oh, I
never
see, it
take it
stays
off,
on there,
so
yeah.
you can't forget.
Now, if you're only using one of them, right? If you have a whole bunch of them, and if you
Oh.
only have one,
If you only have one in the
Right.
shop, yeah, and you have to go in the house to get the other one.
The
yeah.
other
yeah, you
thing,
know you left one.
the other thing we
You left one
learned
on,
is,
somebody's shoe.
I did a pack in I'm confessing all these problems I had. I did a pack job in San Diego, and we have these cool little packing weights. Well, I was trying to rush, and one of them just happened to end up inside
Whoops.
the bag. And this poor pilot that year ended up landing in the middle of nowhere in the Owens Valley in the middle of summer, having to hike his equipment out. And it was like a 2-mile hike for him. And so the next year when he threw his chute for the repack, lo and behold, there's this 5-pound weight that he carried when he didn't need
Good
to.
exercise.
So now we count all of our bags
Yeah.
also.
Just about came in first in the Nationals, but
If you gain 5 pounds,
yeah.
Tried shaving all his
Yeah.
wires and doing all that. It just didn't work.
Okay, here I'm ending this with the skirt of the parachute towards the opening so that this is going to be exposed to the air first. We're going to lock off this compartment. And again, if I have any uneven lines, I'm going to just straighten them out now. Now the loops. How big should the loops be? If the loop is way too big, something can get inside the loop or in between the loop, and you can lock it. That means that the rubber band has to stretch or break in order for it to come undone. The way these loops work, as you've seen, is this. Okay, the lines are locking off the compartment like this. So as you pull on this line, it just opens up and the compartment opens. Okay, if you go to the drop zone, skydiver's drop zone, you'll see rubber bands that look very similar to this. But when you try to stretch them, there's very little stretch. They break at 30 pounds, and when the riggers stow them, they do a loop similar to what we're doing, but they wrap it around 3 or 4 times real tight. The reason they do that is at 120 miles per hour, they want to resist opening. They want to slow down their sequencing, and that's a real good way to slow it down. When we pack chutes for hang gliding, we don't want to slow it down. So we want to make sure the rubber bands we use have good elasticity, okay? So if you have any question, there are a number of different kinds of rubber bands you can use, but what you're looking for is nice and elastic so that when it needs to release, it will do that easily. Okay, so our parachute is now locked off in the parachute compartment, and the loops here are not so big that anything's going to come through them, but they're not so little that the lines on the inside are going to fall out. They're just right. Okay, from here we're going to stow the lines in the line compartment. Different bags have different configurations. Let's see, can you go get one of my bags on the table, please? Okay, this design actually is quite good. And since I keep talking about friction heat damage, oh, can you undo that, please? Not that one.
That one. Good pull.
A new one. Are there any there? Perfect, yeah. Okay, here, if you notice, the line pocket here is real big. And so what can happen after the line pockets open up is everything can slide out. What we've done here is we've restricted the opening. We made a smaller mouth, so after the lines are S-folded, they have to snake out in sequence. And it's still easy to come out because we use a very slippery, it's a silicone impregnated material, so it slides right out. Both ways are far superior to any of the old bags. So there's a little difference. Okay, here what we're going to do is bring the lines up the side of the line pocket. And from here, it goes up the side, then we're going to S-fold them back and forth. If you took this to a drop zone, typical skydiving rigger would take the line straight up the middle, and then they would go back and forth over the lines. And then when you say, why do you do it that way? They'll say, because that's how I was taught. For skydiving, that's a very typical symmetrical, yeah, way of doing it. For our purposes, this is a better way of doing it.
Your way, you're avoiding less friction.
Uh-huh. Friction heat damage.
So this chute is, it is designed then to stop me at terminal velocity if I was to cut
No.
myself away from, not a good idea?
This chute was not designed for terminal velocity deployment. And, yeah.
Don't do it.
Don't do it.
If you're getting sucked
But
into a
it's
black...
not as bad as a lot of them.
Right.
I mean, I would jump this. I would jump this. Yeah, I would still jump this, but not at terminal velocity.
So if you're in cloud suck and you're gonna unhook from your glider and throw it right away.
You weigh
Exactly.
105 pounds.
Then you just get sucked right back up in it. You have to dive away for a while.
Now-
Well, I don't think you get sucked back in. That would be a real killer turtle.
How did you get sucked in the first place?
Well, I think a wing flying a little more, isn't it? Like this thing, what would a sink rate on this thing?
On this particular chute, we'll see tomorrow. I don't know off the top of my head. It's fast.
You throw them off something?
A bridge.
We could.
Who are we gonna throw?
Two twins.
There's nothing high enough in this place.
Okay, so the beauty of this bag is that it does control and sequence the deployment. Now, the issue of bridles. Some of you, did some of you have your bridles rubber
No.
banded in clumps in your harness? No. Nobody did?
I just didn't.
Nobody did? Okay, good. I have seen that before, and perhaps you have, where they stow the bridle very nice and neatly, but then put a rubber band here and here, put it in the harness. And it keeps it nice and organized. But what I don't like about that is when you go to throw your parachute, with this rubber banded together, you have more mass here. And so with the mass and the bulk, you
Get a
can
shorter throw.
literally pull, this weight can pull these open before you have full extension, before those two rubber bands break. And remember, we want continuity.
No.
So some people,
Yeah, we're
some
talking
people
about-
wrap a bunch of rubber bands around there.
Yeah, okay, and so that'll pull all the lines out and you get line dump, which is, we really want to avoid. And if the lines are not tight, if they're all dumping out, you can have entanglement problems. You know, all sorts of bad things can happen. Oh, I know. Now, when you deployed your chutes today, how many of you had your container open all the way?
Mm-hmm.
Yeah, all the way down?
Pretty much, yeah.
Oh, okay. Because often what happens is the last little bit still stays Velcro. Yours did. Yeah.
Oh.
And we like that
Mine
to
stayed
happen
Velcroed.
because that forms a little pocket for your excess bridle. And so even though your parachute, you get it out of your container, you still have a little space where your bridle is housed. And so again, as you throw it, yeah, it doesn't all dump out.
Yeah, my hand was on the top side of the deployment
Ah.
bag.
Good point. Okay, in the old deployment bags, the handles were up at the top, just like this. So what would happen is when you throw your parachute really hard, the parachute deployment bag would go 20 feet and the whole parachute would go dump out right in front of you. And some of you noticed that on your second and third and fourth deployments, that you couldn't get a good throw because the parachute wasn't staying in the deployment bag. Well, about 4 years ago, I got a call from Dave Sharp, and none of you guys know Dave? Okay. Well, Dave calls up, and we were talking about deployments and how the rubber bands have to be fresh. You have to make sure they're still good. And he says, you know, Betty, you've been doing this all wrong. And I said, what do you mean? He said, you shouldn't have the handle up at the top. The handle should be at the other end. So when you throw really hard, the centrifugal force keeps the parachute in the deployment bag till you release it, and then it snakes out in the orderly progression. Well, I hung up the phone. I thanked him, first of all, and then I hung up the phone, and I said, shit, you know, he's right. And at the time, for 15 years, we'd been building him wrong, and it was just so obvious. And so it was a classic example where Dave, who knows nothing about parachutes, could see the solution to an obvious problem, and we were just too close. So as I say, evaluate whether something's really better or not. You know, you too can come up with some simple solution for a big problem.
So you want to put the bridle in the bottom of your container then?
Right. What I like to do
This
is to
handle. This handle
have
still is.
at the top. Yeah. I like to stow the bridle at the lower part of your container because with all of this weight, if it goes down too far, then you're going to have to lift this weight up to release the pins before you can extract your chute. If you have a little ledge of bridle underneath, it helps hold the parachute up so that it doesn't sink down. Does that make sense? Okay, I'm done. We're done for the day. Any questions, first off? Okay, tomorrow, are we meeting at 10 again?
It's your call. Are we leaving our stuff here?
That's your call.
He said he couldn't lock it
He couldn't? No.
at lunch hour. So you may not want to leave
How many
it.
hours are there?
About 4.
But if he's got nobody else coming, we could ask
Yeah,
him.
that's-
There may be nobody else coming, and
is good.
Yeah, 10.
Is 10 good?
And 10 you think it'll go till when?
Probably about 4 hours, maybe 2. 2, 3, 4. And I'll be here earlier. I hope to be here earlier so that I can get a head start on just packing.
Also, I guess
Excellent.
Your handle has to be set up so that when you pull it, the pins pull first, then you pull the pins on the bag.
Exactly. And that's why if you store your bridle under
We're
here, you're more
earlier
likely
than
to
if it's
be able to
flyable.
achieve that.
We could go through a shoot.
If it drops down, then it's harder
Maybe one
to
of us will
achieve.
get lucky and we can have to deploy it for the
And get her to repack it before
Now,
she
if
leaves.
this is too long, that's too long. you
Assuming the
pull
rendering
down,
plan
and
isn't
the
coming for you,
handle's
huh?
down,
Yeah.
you just don't have the
They're saving $1.
Come on, Brenda. What kind of tape is that? Let's have a look at that roll of tape now. We're recording. This is Brenda's hit. Come on, Brenda. Let's go check out what kind of tape this is. Brenda. This here is the gaffer's tape that she was using for holding the chute bridle to the mains, and it is sheer tape. It's a lot like hockey tape. It feels a lot like hockey tape. It's kind of fabricy. We unpacked the chute and we counted the gores and we split them 11 on each side. We did that at this end and we did it again at the far end. And then she just did a 3, and then she folded her corners in at 45, and then she did the 3-layer flap. And here's Brad. He thinks this is great.
Film Terry, look, he's in a
Okay. Hi, Terry. What are you quandarying?
I can't tell you that.
Oh, okay. But you got to fly. Today would have been the most awesome day so far this season.
It's not over. The day is not over.
What time is it? 1:15?
You going? No. Okay.
Going where?
The wife won't let me.
I was going to say, you didn't talk to Hun yet.
Gotta check with the boss.
Well, you're not going? You coming with us?
No, this was his hang gliding for the month.
Nowhere.
This was his hang gliding for the month of May.
That's right. I threw my chute.
Rolling.
Put the whole thing upside down.
No, start anywhere. So you're going to hold your hand like this. You're going to reach into the middle of the gore. You're going to sight down. You're looking for any light coming through, and you're looking at stitching. And then
For dirt.
and dirt, yeah. And flip it over. Okay.
Okay. So you hold it like this. We look down inside. We look for light. We look at our seams. Mostly just at this end, I guess.
The whole thing.
You look for light. You look for dirt will fall all to the same fold, the last fold. I really don't know what I'm looking for here.
I've already lifted it off.
Yeah.
So this is called flaking it.
That looks like a quantum chute.
Whoa.
Are your initials on it? Did you make it?
No. But I knew it was made from mesh because it uses the silver thread and it was black.
Like you change the thread every year, do you?
No, every so often we change something.
Well, then,
For
in fact,
instance, we
the supplier
changed
wanted too much
Well,
of the black thread, so you had to get the silver thread.
Hold for.
We flip over some of the gores and we just raise it up.
Okay, so all of our
And what we're doing is shaking it
gores have been placed.
and look down at the air channel. And
So you're just picking anyone in particular? Like
Anyone.
Roughly splitting it?
doesn't matter. But what we're looking for here is any excess material hanging out. See?
Oh, okay. Like that.
Like that.
Excess material down there is bad.
Yes.
So you should
Okay.
just see all the folds of each core.
Yes. So here you can lay it down and flip it over, whatever is your fancy.
How come this one won't slide?
Because
Oh,
you
that's
had
the
one
one that's
passing
not
tab
tied.
not on.
Can you yank on that?
Which one?
Good. It should be close.
Yeah.
Very close to the
Your
top,
right
the
hand?
second one. Over here.
Yeah.
Yeah, that's the guy. That's got to be pulled on the inside. Okay, so now I have to find the center.
Now you have to get it on the table somehow. You can flip it down to the table, or you can divide
Flip
it
it
in
right
half.
over, you think?
Yeah, that's what I like.
Okay. Can you grab
Either
that one
way.
and flip the whole thing over?
Good. Now you're going to divide it in half. Good. Hold on to your lines and put a little tension on your thumb as you pull it over, because you want any material that's kind of folded in, you want to make sure that it's clear of the air tube.
4, 5, 6, 7.
You weigh your
11.
Good. Now start on the bottom of the other side.
Just put these guys in. Yeah. 1.
Good.
Now you fold these corners in.
Okay, well from there you need to count your
that side
goals
first.
at the top and make sure that you have the same number. As you walk down, Steve, as you walk down,
Oh,
you want
okay.
to feel the bottom to make sure there's nothing
Make
tucked
sure that
under.
I'm still on the same board all the way.
Exactly.
Feels right. So I guess I still have to hold it here, or does
So
the
start at the-
tension's enough?
Right. Start at the bottom and that's right. Good. Yeah, you can even put your hand in there and kind of spread it out so that it's nice and smooth.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay, you do not want rubber band there.
No, I just do that so I can move it around. I'm just gonna lay that in up here.
No, this we're gonna lay in down here, on the bottom, and then you'll take the rubber bands off.
Hey Betty, do you just run your hands down it to kind of spread it out a bit?
Yep, in fact, I like to use my forearm.
Your whole forearm?
Yeah, because that way there's usually,
No air at
it
all in
works
there?
faster and you usually don't have snags. On your hands, if you have hangnails or jewelry on,
Oh, okay.
it's easy to snag the material. Very nice.
Now we do our corner pulls.
Your 45.
Do I bring all this together?
Yes. And at this point, in fact, you want to sight down to make sure the air channel is clear.
Yeah.
Okay.
You just don't want any folds hanging into there.
Right.
Hang on here. Hang on here.
Well, actually,
That
if you
seems like
hang
it
on
needs to be
up
there.
here, then you control the fold.
Creases okay in there?
Uh-huh.
Yeah. You're gonna get
Yeah.
them anyways, right?
Now, leave a nice air channel here.
Oh, so you leave this kind of loose, the air to get in there easier. Okay. Now fold
Thirds.
thirds.
Now, if you pull down as you do your fold here, it'll fit back right over.
Then I run this air out again one more time.
And now we're
Or do
going to
it.
fold this one over. And now we're going to do thirds again.
You are?
This way. This way. And you can run the air out from that end down to the opening. And you're ready to put it in.
Oh, so we don't even need to weight it?
Plug it back in.
Okay. So take the tension off.
No, it's,
Now never, ever, ever leave this thing.
that's right. It's not that complicated.
No, you just don't want to forget a
A
part.
step,
and
yeah,
move,
yeah.
Like to forget this in would be pretty catastrophic.
Yeah, yeah, yeah.
Well, I mean, actually, let's look at this. This is coming out here, and then you have a short part.
I can't do this alone.
So all this is going to fit into this little bag.
Well, no, this is, excuse me. Yes.
Okay, does it matter? So I just start in a corner and just start zigzagging back and forth?
That's right. Now, it's easiest if you
Measure
hold,
first? Yeah.
no, if you hold this against your body so
Yeah.
you have something to push against.
Oh, I see.
And to begin, if you do a couple, see how I'm rotating this up?
Yeah, I was going to hold this here. I was going to hold the bag there to get an idea, but you've probably memorized the right.
Yeah. And from here, you can put the folds in and then continue just folding it as you go.
So you don't have to stuff that first one way down in?
Not yet. It will be
It'll all,
ultimately
it'll all.
finishing like that. Let's see, should I let you struggle?
Yeah.
Okay.
I'm good. Man, I'm looking to finish up nice. Look, yours always seems to
Okay.
Don't you
Why
always
don't
end
you
up
pull it out a little bit?
pull it out a little. And stuff it in, stuff a little more in.
Is
Get a little bit more on each fold.
yes.
Yeah.
So it comes out.
So it ends up with one final flat. Yeah, I can take it out. like depends on what you put in there. I get you. I guess we can tie off this first one. Okay, I'm not sure if this first one's supposed to get looped in there too. Do we do the elastics right at that point, or do we put a few rolls in there?
Well, actually, my personal preference, it doesn't matter, is to start at the far end. And so you'll begin with your first locking stove here, so that you can pull tension, make sure all your lines are nice and straight here, and any excess will just be in the bag.
Right.
And then here you can do your first loop.
Okay.
Okay? Go.
There's a knack to everything, isn't there?
Okay, very good. Stuff the excess of line in the bag, and then you go to your next locking stove.
Right. So it's the same that we don't want any lines falling out, but we don't want enough that things get snagged in there.
Yes, perfect. Okay, from here, just point where you're going to stow it in the line pocket.
I'm going to take it down to this far corner and then start zigzagging
Very good.
that way.
Exactly.
Again, trying to keep your
So it
lines
takes
all even.
Takes it to the corner of the last elastic band? Like not across.
Yeah,
Okay.
and remember what we're trying to avoid is friction, heat damage. So we want to avoid the lines crossing over. And that's why you just go to the closest corner. Now, you might want to try a flat hand and bring your fingernails down just a little bit, and you can push the line real easily. To guide it, you can even keep one finger up and push the lines. Or I can give you a packing paddle to help.
So the hand basically won't fit in there?
Well, let me take a look here. Let me try.
I think you need a small hand.
From here, okay, what I'm going to be doing, if you watch my hands inside, is something like that to guide it. So from here, I know it goes up to here. So I can just keep my hand fairly flat and put it up there. Do you want to undo it, please? So with a flat hand, you can guide it.
So now you
So
just
here-
go, now just,
Yeah, go for it. That's right.
switch hands, or you just stay with the same one, I
Well,
guess?
whatever's
Whatever's
comfortable.
We're trying to really cram it down in there? Is there lots of it?
No, there's not that much. The beauty of this deployment bag is you can see the lines. So you can see how you're doing. Now, if you notice, sometimes one line seems to be longer than the rest, and it doesn't mean you goofed.
It's just
that
somewhere
it-
on the inside of the corner somewhere.
Right,
else
it
that
seems
you-
to keep going on one
That's
side
why
or
if
another.
that's why I guess you want to correct that every loop you stick in there. Yeah.
So I would have to put the bag
Oh, we could have it in the air show. If you want to fire it, we could fire it in the air show.
Yeah, have a deployment.
Yeah. Shoot the rocket, it goes out and pulls a little drogue chute or something out of your sock there. And it inflates and it has a little, just a little baby canopy. Yeah, sure.
How far does the rocket go?
Bounce off the side of the neck.
Okay, I'm going to, this is about it. The rest is,
No, well, that's good for now, but we'll.
Chorus line?
There we go.
there you go.
She's getting used to it now.
Okay, you want to make sure that the paraswivel is inside the line compartment.
Okay.
Okay, the reason is
Paraswivel
we don't
inside.
want the extra bulk outside pulling the lines prematurely.
Oh, okay.
And I'm gonna just tuck this excess back in here. Make it look nice and clean. From here, going to close this off with your last locking stows. And we're good to go.
Okay. Thank you very much.
You're welcome.